Okay, we're going to talk about the double angle formulas. I know it says double and half, but I think I'm just going to concentrate on the double angle formulas in this video. And they're just listed here. So we did an activity in class that kind of developed sine 2 theta and cosine 2 theta. So here the formulas are, so sine 2 theta equals 2 sine theta times cosine theta, and cosine 2 theta equals cosine squared theta minus sine squared theta. There's a couple alternate forms, and these come from the Pythagorean identity, because if you replace sine square theta with 1 minus cosine square theta and simplify it, you can just have it in terms of cosine squared theta. You can also have it just in terms of sine squared theta. So if you just wanted a cosine in your answer, or you just wanted a sine in your answer, you could use one of these alternate forms. So this first example, we are finding the value of sine 2 theta. If you're told what sine theta is, it's 3/4, and you're told theta is between 0 and 90 degrees, which means it's in quadrant 1. So on this problem, I would start by writing down the formula, which is just 2 sine theta cosine theta. So if I want to evaluate sine 2 theta, I'm going to do 2 sine theta times cosine theta. Now, I know sine theta is 3/4. I don't know cosine theta, so I need to find it. So I build a triangle. You could also use the Pythagorean identity and do 1 minus sine square theta. If theta is here, I have opposite over hypotenuse. So 16 minus 9, we get 7. So this would be the square root of 7. And that means cosine theta, since theta is in quadrant 1, is root 7 over 4. So then sine 2 theta is 2 times 3/4 times root 7 over 4. I'm going to do a little bit of simplifying here. So I get 3 root 7 over 8. The nice thing about the double angle formula is you don't have to worry about what quadrant 2 theta is in, because remember we're solving sine 2 theta. It gets taken care of in the process with the signs of sine and cosine, so you wouldn't have to worry about that. So here's another problem, and I believe this is, yeah, we still have sine theta is 3/4, theta is still in quadrant 1. So now we're just finding cosine 2 theta. So to find cosine 2 theta, look back at the formula. It was cosine square theta minus sine square theta. We know sine theta is 3/4, and we know cosine theta, we just found, was the square root of 7 over 4. So now cosine 2 theta, I'm going to square both of these. And remember, when you square a fraction, you square the top, square the bottom. So when you square the square root of 7, you get 7. So I'm going to get 7/16 minus 9/16. So my answer is negative 2/16, and that's cosine 2 theta. So think about that. Remember, sine 2 theta, we said was 3 root 7 over 8, which is positive. So sine 2 theta is positive. Cosine 2 theta, oh, I could have reduced this, is negative. So that tells you something about the quadrant that 2 theta must be in, because remember, theta is in quadrant 1. So it must be that 2 theta then is in quadrant 2, which makes sense because if you double the 90, it's 180, so it would have to be somewhere. It must be in quadrant 2 because cosine is negative and sine is positive, so that would be a quadrant 2 angle. So, but we didn't have to worry about that because it just kind of worked itself out when we came up with a negative for that problem. And I'm going to skip. I just wanted to show you an example, so we won't worry about doing a practice problem there. And then next would be the half angle formula. So I'm going to hold off on those for another time. So this was a short video.